code. You also have a simple debugger that you can use to set breakpoints and then inspect variables. You also have a network tab, which you can use to monitor HTTP requests made by your application. By HTTP requests, you could monitor requests, you could monitor the response, you could check the request header, the response header, basically everything that you need for an HTTP request, you have it there. You also have a login tool inside the Dart DevTools that basically that you could use to view all logs and errors. By logs, right, the logs could come from your code, it could come from the Flutter engine. As long as it's a log, everything goes to the login tool. Then you could also use that dev tool for performance profiling. You could capture CPU profile for your Dart code so that you could identify performance bottlenecks, right? Oftentimes, when we talk about performance profiling, you do that in profile mode, right? Flutter has three different build modes. Talk about the debug mode, right? Very common debug mode. When you're working, use debug mode. We have the release mode. Of course, that's what we ship out to our end users, right? Then we also have the profile mode. Profile mode is similar, is close to release mode, but with certain debugging overhead. So you want to profile your application, have proper performance analysis of the application, right? Check the heap memory used by the application and everything. The best way to go about it is, in profile mode, because you have close to release capabilities. I also, one catch is that the profile mode only works on an actual device. So profile mode does not work on emulate your emulator and your simulator don't work with it works on your actual device because you are profiling an application on an end user device, right? So you have real data, right, of what the CPU profile is like, what memory profile is like, etc. There are different ways you can launch that DevTools. You could launch that DevTools from a command line. You could connect that DevTools to a running instance of your app. If you're using Android Studio, you have a button to fire that DevTools when you run an application. If you're using VS Code, you can also fire that DevTools right when you're running your application. So yeah, that's like summary or background of what that DevTools are. So is there any question before I proceed? Is there any question if I proceed? Yeah, so I'll assume there is no
I think
question.
there is no question.
Yeah, I'll assume there's no question. So the answer of
Yeah.
question will go to why we are here. So in this session, right, I will show us the basics of that DevTools. You don't need to know, you don't need to, I don't know, store how that DevTools work in and out in your head, right? You just need to understand the basics and implement those basics, right? By basics, we are going to cover UI, debugging your UI. We're going to cover debugging memory, right? We're going to cover debugging and checking for chunks. And then we're going to explore other tools like the login tool, the network tool, and yeah, whatever tool we can lay our hands on, we are going to look at that. Okay, so right before yeah, I want hope we can see my screen, code editor, and my emulator. The first thing we have a very simple Flutter application. It just one that's the bottom navigation bar with three items: demo view 1, demo view 2, and demo view 3. So there's nothing big or deep about this application. So I will just launch the application. Then for me, right, my widget inspector is set to always come on whenever I run a first application. So that's why it says here, but let me take it out. So yeah, this is a very simple application. This is the very first demo. So with nothing deep here. We just have um, an app bar. We have um, some text and some button to try some action or cause some problem or whatnot, right? So I will be showing how you could debug UI with a Dart dev tool. So let's see. It's a very long text. One very issue we have with UI is overflows, right? So let's cause an overflow. It's a very very long text. So if I tada, you have an error. I think some earlier versions of Flutter, you're not seeing my. Can anyone else see my screen?
Yeah, I can see your screen.
Uh, okay. Perhaps Benjamin has to pin the current active tab or something. I don't know. So yeah,
Yeah,
this one
yeah.
we have an
He has to pin the this thing on his
on the
screen.
screen. Yes. So we have an overflow here, right? What I wanted to show has disappeared. Anyway, I think when you're running from a terminal or some earlier versions of Flutter, you will actually have a link to the Dart dev tool embedded here in the response of this overflow error, which you can click and open the Dart dev tool. But I think going forward, IDs like Android Studio and VS Code just brought that capability out of the box. Yeah, they allow you to be able to let me replicate it. So yeah, it is a render box overflowed by 189 pixels on the right, and you can do inspect widgets. So it jumps to the exact. Um, Let me close this code a bit so we can. As you can see, it jumps to the exact component that's having the issue in my layout explorer, right? So this is the layout explorer, right? What you could call it your Flutter widgets explorer. But yeah, so we have it tells us, oh, we have a row. Inside the row, we have a text. The text has an unconstrained width, right? The width is unconstrained. And then it says what does it say again? Oh, the flex is null, flex fit set to loose, height is 36, unconstrained, height is 36, unconstrained. So yeah, I think for different widgets, you always have certain, toggles and defaults on your layout explorer, which you can play with to see what to fix it before without even changing the code. So we could set fit to tight. It does nothing, right? So we still have our box remains. Set it back to loose. The box remains. We could go from flex null to flex zero. The box remain. Flex zero to flex one, and of course, it's also hot to load the application, right? So whenever you make any change to a variable, from the layout explorer, it does hot reload on your emulator or your device you're running on. So you can tell if it fixes the issue or it does not fix the issue. All right, so setting this to flex value of 1 fix the overflow issue, right? Now, the layout explorer does not write the code for you. It just gives you values by which you can tweak, right, to fix the UI. It's left for you to go back to your code and to make that change, right? So since it still needs to set a flex of 1, where the flex fit is set to loose, what I want to do is to go back to my code. Um, so we still have our broken this thing, still broken. Don't think about this. The layout explorer deceived us, thinking that it's not there. What you have to do is you want to be sure that it's still broken. Let me just show. So it's still broken. The layout explorer just showed us what could happen when we change those values. So it says to set the flex value to 1 and then I think the flex fits to lose. So that implies we have to use, I think, a flexible widget now. Is the fits. Uh, flex. What's the type now? Flex fits. Okay. Just lose, and then the fix, and then what else? It says the flex value to 1, right? Yes, that fixes that bug. I think by default this fix value is already on lose, right? So we could just remove it, right? So that's a flexible widget. Another flexible widget we have is expanded, right? Expanded is another flexible widget. By default, expanded has the flex value set to 1, right? So you could also use an expanded. I mean, it's basically a flexible widget whose flex is set to lose, and then the flex value is 1. So, right? Yeah, so it's basically the same thing for even more complex widgets, right? It's always when it happens. Always when it happens, you could go ahead to inspect that component in the widget inspector, and then tweak the values that the layout explorer gives to you, right? And when you get to the value that fixes the issue, you just come back to code and then you know make those changes, right? I think oftentimes people tend to not use the layout explorer for things like this. I think that's because by default, Flutter allows us to focus on the end result, right? Not on the how. So by that, it means we have some kind of description of what the UI looks in our head. So oftentimes we just tend to jump into the code and start modifying the component to see what works. Right? For more complex components, right, it might take us some time, but with the layout explorer, we could just play around with the values, and then boom, we guess what works. Yeah, I think someone raised up their hand. Was that for a question? All right, I'll guess that. I guess that's not was a mistake then. Okay, so that's. Oh yes. So let me show you. So then when the layout explorer gives you, let me take it back. When the layout explorer gives you options to use, let me revert it. So I'll show you how I know what to do. I mean, that is debugging. We're debugging, so I'm sure I know what to do. So I'm going to. So when you come across an error, very first thing you want to read the error description, right? It says a render flex overflow by 189 pixels on the right. The error causing widget is raw. You can inspect this widget using the inspect widget button in the VS Code notification. This was the button we followed to check the layout explorer, right? We have some other information on the edge of the render flex that is overflowing has been marked in the rendering with the yellow and black stripe pattern, usually caused by the content being too big for the render flex. Then you have a recommendation. Consider applying a flex factor, e.g., using an expanded widget to force the children of the render flex to fit within the available space instead of being sized to their natural size. This is considered an error condition because it indicates that there is content that cannot be seen. If the content is legitimately bigger than the available space, consider clipping it with a clip-rex widget before putting it in a flex, or using a scrollable container other than a flex like a list view, right? So basically, it's all this put together, right? That informs our decision. However, for bigger, there are times that you come across a very very large, exception on your console, right? You don't need to worry about the whole thing. You just have to check the part that references your code, right? Like here, now it references the demo1.dat file, right? So let's say you have a very long exception that was caused by the rendering library. You don't need to read through the whole thing. You just need to go through the exception and find which part of the exception is referring back to your code, to code written by you in that project, right? Then from there, you would have some insights on to as to what to change. Then you can use the layout explorer to tweak all the values that were given to you. Does that answer the question? I want to believe that answers the question. Okay, thank you. Thank you. So, okay. So yes, so that's like how to attend to UI issues, right? So let's try something else. Let's go to something else. I have some list view here, and I have another list view here, and yeah, demo two. So I have a simple list view, right? Where if the index is 20, give me some widgets, and for every other thing, give me a text widget containing the index and index value, right? So yeah, so I think I was trying to replicate having I think I was trying to what was I trying to replicate here? I think I was trying to replicate Janks, right? And then of course Flutter now uses impeller going forward. It was kind of hard to replicate at some point. But then I think I was able to, work around it. So I just, try to stack a text widget 1,000 times on itself. That hopefully I will feel a performance issue. I think when I got to 10,000, 100,000, it froze up the UI. So I could tell that, yes, the junk is happening. So, yeah, demo two, a simple list of items, 100 items, nothing deep, right? Separated by a size box of height 30. So, yep, I could tell, right, this free flowing, nothing deep. But when you get to 20, you could see that it's kind of slowed down before it loads the others, right? And you could attribute it to Janks. So what are Janks? Janks are basically visual stutter. Simply put, Janks are visual stutter. You are going through an application, and then the easiest way for you to recognize junk in an application is you being uneasy while using the application. Take for instance, you are going through an application or you are scrolling through. You could tell that something lagged. You could tell that a part of the app kind of lagged, right? But you're not sure what exactly happened, right? That's a visual stutter. You can feel the uneasiness, but you can't exactly say, right, what's made you uneasy there. Right? So that's junk, right? Um, yes. So how do we attend to issues like that? Let's see. So let's fire up our Dart DevTools. Mm. So we have the widget inspector, CPU profiler. We have a memory page, performance page, network page, login page, and we could open the full Dart DevTools in the browser. I think I'll prefer to open the full tool in the browser. So we could, so um, a moment, trying to arrange the whole thing. What information? Entire screen. Can you see my screen now?
Well, not yet. I think you have to share.
Yeah. Okay.
It's not showing.
Try to share. Not sure why. Mm. All right. Yeah. So this the full Dart dev tool itself, the full suite of the tool. I just fired that DevTools right there in my browser, right? So I have emulator on one side and I have that DevTool on one side, right? So this is the Flutter widget inspector that we used earlier, right? And this is layout explorer. So yeah. Okay, so back to the issue we're trying to address. We're trying to address a performance issue here, right? So here we have some kind of stutter somewhere here. So how do we attend to such? So we have the performance tab on that DevTools. I mentioned earlier that the best way to measure performance, right, is to launch the application in profile mode and to run it on a physical device, right? You get the best benchmark. In fact, it even tells you that if you're running your app in debug mode performance is not an indicative. It's not indicative of release performance, but you may use debug mode to gain visibility into the work the system performs, which is pretty fair and okay. I mean, yeah. For the we have other things like CPU profiler and whatnot. All right. So how do we use the performance tool? Um, Two things are very important here. Uh, yeah. The very first thing is the performance overlay. Performance overlay tends to overlay a graph on your application. I don't know if you can see my emulator clearly, but there's some kind of chart on it. I'm trying to see if I can. If you look at it towards the top, you have a chart. Let me see if I can maybe color the chart or something. Mm, mm, can we see the chart clearly? You see where you have raster with a max of 75.2 milliseconds per frame, and then you have a UI max. That's this and this. Yeah, in the earlier Flutter versions, like it was like a full graph that you have there. I think right now it's just values, and then every other thing you could see it from your profiler directly. So yeah, let's find out what is causing an issue. The very second thing here is the enhanced tracing, right? Whenever you have janks or uneasiness, right? What you want to do is you want to track widget build. I mean, in Flutter we say, I mean, everything that your user sees, right, or interacts with, mainly widgets. So you want to track uh, the widgets builds, right? Very important. Performance overlay and the widgets build itself, right? You could track layouts, but layouts goes even deep to tracking every render object. So oftentimes you don't need to do that. Tracking widget build is mostly enough. Then, of course, our chart tells us how to read these charts we have up here. You have the frame UI, this color. You have the frame time, raster frame time. You have jank and slow frame by this color. And then there you have shader compilation, this color. Let me zoom in a bit. That. Okay. And then, of course, everything here, 60 frame per second, that's around 16.67 ms. Yeah, so, and here we have the exact value in terms of FPS that your application renders. So yeah, you know, let's go. So we could scroll. It's everything being locked, right? Then we could come back, right? And of course, we have some stutter here and there. go back, 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 go back. Yeah, so everything indicated by these guys, these guys, these guys, these guys, these guys, they're visual structures, what you call chunks, right? This guy, they're everything like they already die in the accepted file. So how do we know what caused this issue? Let's clear and go this again. Mm, let's see. Crack. Okay, no read chunk down here. Okay. Let's see. So this we read this using the timeline of events graph. This we use the timeline of events graph. So what a timeline of event does is you see every event that happened at that particular instance on your graph, right from the build method down to, let me see, let's take this. Um, Let me reduce this a bit so I can bring up the graph. Please, if you can't see my screen at any instant, please let me know. Let me just okay, maybe I have one shader compilation, chunk, shader compilation. So let's look at it. A junk happened, one junk happened there, that's slow frame, at the same time, some kind of shader compilation. So you might want to look into that and see what true is. By default, shader compilations themselves, I won't call them junk, right? But having shader compilation, right, and a slow frame at the same time tells you that something is fishy there. All right. So what you want to do is this how to read the graph. It's very very simple to read the graph. You don't need to worry yourself about every other thing that's happening on this timeline of events, right? What concerns you starts from the build method, right? When you look at your widgets, your widgets, one very important method of your widget is the build method, right? I mean, that's what renders visually on the screen. So you look for the build method itself, and then you read everything from the build method downward, not not every other thing. Every other thing that you see here, you have things like the GPU, rasterization, the renderer, you have some animator and up there, so that's not a problem, right? Everything we need starts from the build method. We have the build method, we have the build method, kid, subtree, keep alive mixing, and whatnot. So to find the junk is very simple, right? The color coding this, right? Um, so we know that this is the guy that's throwing our error just from the color coding. I mean, let me take this up. So we know this is the guy causing the error, right? And this is a stack that's inside a widget called something expensive, right? So how do we So the next thing to do here is to go to the part of the code where we have this component called something expensive that renders a stack. But what does this stack do? Ask the question. What does it do? Like throwing some kind of chunk. You could expand. You could zoom into it to see what's happening, right? So after what is being stacked. So when you zoom into the stack, you realize that we have text, text that are stacked on each other, right? You could see that under the stack pages, you have text and text and text that are stacked on each other, right? How do you know they're on each other? They are all on the same line, right? If they were in a column or maybe in a row, as long as they're on two separate parts of the tree, right, they would follow each other. But since they are on each other, you have them staying on the same line. So it was it's what you have here, right? So basically, from looking at this, you can tell that you have stack of text, but you can't tell how many texts have been stacked on each other, right? You can't tell that. So yeah, that's what causes our junk in this case, right? And I think it's yeah, it took around over 27 ms, right, to render just one frame. Where ideally you want to render under 17 ms, right, at 15.67. So yeah, that's bad for business. That's bad for business. So in that case, when you have identified the issue, of course, the next thing you want to do is to come to your code, right, and fix the issue. So it says a stack widget, right? A stack. So yeah, back to my code editor. It says a stack, right? Something expensive and a stack. When you're in a very large code base, you might not know where something expensive is. So you could just like use the exact name that it tells you. Oh, it says something expensive, and it was used here at index 20. And what does it do? It basically stacks this text widget on itself 1,000 times. Yeah, so 1,000 times, right? That's like what has caused the issue. Of course, this is a very simple demonstration. In your own case, it might be something else that's causing the issue, right? All you have to do is to pinpoint out where you have the junk in your chart, right? Then come and read what you have below the build method. You would find the components or the widget that causes that visual stutter. Then you can go ahead and fix it. Yeah, so I don't know. For me, I don't need a stack of text now. Why do I need a stack of text? So I could just yeah. So if I don't have a stack of text. Mm, yeah, my app should do pretty fine without that jargon. Yeah, so yeah, so that's how we attend to performance issue, right? You just want to replay certain actions on the application, right? Then come and check. Then go ahead to check your Dart DevTools, your performance profiler, to see the charts and at what instance do you have the junk. Then explore into that instance and find the component that causes it. So before I proceed, any question?
Sorry, quick question. Good evening, Chief. How did you track can you just walk us through how you tracked the exact something expensive? Does it always show up like that? Or is there any
Yes,
special thing you do?
yes. There's no special behavior. It's always like that, right? Come on, let me. There's no special behavior. Right? Your junks have no special behavior. The only what you just need to do is to understand how to read these charts, right? And follow this case. Everything like blue, light blue, they are all fine, right? So there's no special behavior. What you're looking out for is frames that have chunks and heavy shader compilation, right? So what I have is these are shader compilations. I think I just resolved the junk issue just now, so you can't find a junk, right? These are shader compilation issues. Well, ideally, what you want to do is to look for bars that are exactly of this color, right? Then click into them and then view the chart. View the chart. For shader compilation issues like this, they don't have any build method. It's not a widget, right? So they don't have any build method. But for widgets, you have a build method. So what you want to do is read everything under the build method. Basically, it arranges itself the way you have your widget tree. So there's nothing special there.
Oh,
Clear?
sorry. What if there's nothing under the build method?
Or you won't have anything under the build method if every widget, right, in Flutter has a build method, right, and your build method returns something. So when you are profiling, right, as long as the issue is caused by components, you would have a build method and
Build
something
method.
under the build method. Yes,
Okay.
yeah, because your components are arranged that way. Widget build method, then you return another widget. So that the same way.
Okay. Yeah. Thank you.
Yeah. All right. So yes. What else? I was going to show something. Okay. Yeah. Then we have the third. I think I still have my. Let me switch. Yeah. So let me remove this performance overlay. Let's open my screen. Yeah. So yeah. Demo theory. Yeah. So I'm going to show. I don't know what I'm able to show, but let's see what's going to happen. So yes. You should be seeing. So you're kind of looking at this. I don't know if you can tell what's going on looking at my emulator. Anyway, for the material, I want to show us how we can debug methods that are consuming heavy resources. Right? Out of the box, looking at an application, playing around with it, you can't tell if anything is consuming heavy resources, right? You can't tell if making call to this method is going to consume heavily on the user's CPU. You can't exactly tell, right? So you can't use the performance chart to figure out what the problem is, right? Performance chart is to figure out what causes visual stutter and chance in the application. So how do we profile against resource intensive processes? And that's how we go about it. You have a CPU profiler, right? Just how the memory profiler. Um, um, yeah, please ask a question.
I see something like shader competence
Compilation.
that rates in like on the charts like
Yes.
yes
Shader compilation. Yes.
yeah is it like if anything show up like that rate is it okay or
Yeah.
is
So
there
shader compilation, right? They are not.
yes
How do we simply explain what shader compilation? Well, they are not caused by your components per se, right? I think shader compilation is a term that we use to describe the process of where um the framework uses OpenGL, right, to load shading scripts that you use as shaders, right? And oftentimes, they are most people tend to say they're usually associated with animations, right? But these are not processes that you can control. The whole shader process, right, is controlled by the engine itself. So you don't need to worry yourself about shader compilation issues that you have displayed on the graph, right? Where what or where you might have an issue or an issue that might pique your interest is when you have a shader compilation issue alongside a slow frame together, right? Like having it together, like side by side, like this, right? That's like one thing you might want to look at. You have shader compilation alongside a slow frame together. But out of the box, you don't need to worry yourself about shader compilation, right? The engine is the one that does that. And you don't need to think about what it's doing to the shaders, how it's using it, except you are actually working with shaders, right? Which is another topic entirely. Okay, so where was I? Trying to let me see. I wonder why it's not recording. All right, okay, it works, it works. But there's meant to be a chat. My oh. Anyway, this is how we debug with the CPU profiler. So what you want to do is you want to record CPU samples. By record, this what this does is when you record, what this does is as you go through the application, right? It takes snapshots of the application. What process did you take? What method was called? What function was called? Right? How many times was that method? Did you hit that method? How many times did you hit that function? Right? How many times was it returned? Yeah, so that's exactly what happens when you record, right? And then when you stop recording, you have more like a chart or a report of the whole CPU sample that we're taking during the whole process. So yeah, I would record and we'll do some. I'll record and we'll do some moving around to see what's going on. So yeah, I'm recording, right? Recording CPU samples. Then just going around the application, just going around. Then I will stop recording, and we'll see what the report looks like. Yeah, this is a full report, bottom-up call tree, method table, and CPU flame chart, right? So the CPU flame chart itself is a chart of frames, right? A top-down view of what takes all your time, or what takes all the time. That's what you have in CPU flame charts. So it's a top-down view of what takes all the time, right? So a chart. This is all. These are all processes that occurred during the CPU sample, right? Some of them are done by the framework, render object, layout, whatever. Then we have this heavily colored in demo theory build, right? Inside demo theory build, it says from line 22, right? Then we have all these processes that were called, and it's coloring it heavily, right? Fibonacci. Right. So that basically your CPU flame chart is just a chart of all process that occurs, right, during the period of recording and taking snapshots. Right. So how do you read this? First things first. Personally, what I like doing is going through the bottom-up process or using the CPU flame charts, right? By using CPU flame chart, I can just by scrolling through it, I can tell what processes are heavy, what process is framework process, right? These are framework process, render object, render viewports, not a problem for me. But like I said, mentioned earlier, where I have my build method, right? I'm concerned with anywhere I see build from my components. This is one of my screens, the material view.build, right? After it says Fibonacci method. So I'm concerned with what's going on with Fibonacci method, right? The other way to read this is using the bottom-up approach, right? Bottom-up approach is basically puts the method that was called the most at the top, right? Then every other thing just below it. Okay. Now looking at this, um, it says the Fibonacci method was called the most in the application, right? So, and it tells me I should go to demo3.dat. That's exactly where to find the method, right? And when it keeps calling itself, right? Calls itself, then demo3 build again. Inside demo3 build, we have a list view of item and every other thing, right? But I'm not concerned in looking at demo3 build because when I look at the amount of time that it took the material build to render, you see, yeah, 0.01% the material view itself. For the Fibonacci method itself, 71.67% of the rendering time was trying to figure out what is going on with the method Fibonacci, right? That's what this reads. This reads 71%, 71+%. So Engine was trying to, compile the method and tell us what method it's doing, get its output, and then render. Then to render the widget tree itself just took 0.01% of the time, which is basically expanding it. It's a list view separated list of items. So yeah, in that case, I want to check why Fibonacci is being called over and over and over and over again, right? Why it is taking 71.67% of the time. How does this translate oftentimes to code? Right? It will translate as heavy processes that you want to make an asynchronous method, right? This will translate to heavy processes that you want to create a new isolate for, right? Take for instance, I think one case I've used recently is when I was working with images, right? I pick an image picker, then I try to convert that image to base 64 and then send it, right? So I think that process, I took a lot of time to render and to complete itself, right? And then we have to move that process to an isolate. So things like that used to show up in this format. You see how many percent of the whole time was spent trying to, figure out figure out the response for the method, and then when you expand it, you realize that most of the time was taken up by the Fibonacci itself, and the other little time was taken by the widget tree to render itself. So that means you should go back to the Fibonacci method and see what's going on. All right. So in my case, I would just come back to code and check what's going on. Right. It says the code says it's in the material, right? I think it's the material. So this is here. The material line is, yeah. So we have a Fibonacci method right there in the build method. So this means that whenever this widget renders itself, Fibonacci, whenever it's a widget build or rebuild, right, Fibonacci is always called over and over again, right? And Fibonacci keeps calling itself. So when you render this component the very first time, Fibonacci is called. When there's a rebuild, Fibonacci happens again, right? And Fibonacci keeps calling itself. So these are expensive. These are very expensive calls, right? And the way by which we attend to things like this, right, is by moving this guy out of the widgets, out of the build method, making it some kind of an async call, right? Like this, you have to await it before you proceed, or you shift it to a new isolate entirely. So this is how you debug and check for expensive methods, right, in your application. Yeah. So I think I showed the bottom up and the CPU flame charts because those are like the more intuitive way by which you could read a CPU profiler. The other process the call tree basically just dumps the whole tree for you. And I usually don't advise reading the call tree because you might not get anything useful from it. This is the call tree. Imagine having to read through all of this. Yeah, so this is the call tree. So imagine having to read through all of this guy, right? So I have things done by the engine. As you can see, 0.0%. This guy did not take so much time to render to perform the operation. So it means I will have to keep going through the whole thing until I find what the issue is. I don't have that time. So you want to use the bottom-up approach, right? Where the most expensive method is on top. So going here out of the box, I know that anything I see up here, they're like the guys that have the problem, right? So I just want to check them. Oh, this guy used up the 1+ % of the whole time to compute itself. So what's going on? I checked there. The flame chart also similarly, I want to check what happens after the build method. Right, where I have build method, check what happens after then. The method table is a table or map of all methods that were called. Then the call tree is a tree of all calls or all process or all methods that goes on in the application. So there might be method written by you, there may be method from the Flutter engine itself. Yeah. So I just advise the bottom-up approach and the flame chart instead. Yeah. So what else? What else do we have? What else? What else? Yeah. We also have memory, right? Similarly, the best way to check all this, the best way to measure this accurately is using a physical device. However, with your emulator, you only get an estimate or idea of what's going to happen. The memory chart too is similar when you let me clear the chart. Sorry, let me clear it. So I just clear the chart. Find memory, refresh. Yeah, so when you do refresh, right, what you have here are all classes that the application is using. I have some homepage states. I have a demo 1 view, demo 3 view, demo 2 view. I have some widgets called something expensive. I have another widget called my app, and I have homepage, right? So what you have here is basically all classes that are used in the application. They are all logged here, right? And then under size, you have how much of size or in memory are they consuming. The home page states consume 0.1 kilobytes, right? Demo 1, 32 bytes, demo 3, 32 bytes, demo 2, 32 bytes, something expensive, 32 bytes, my app, 32 bytes, and homepage. So this part is basically very useful, right, to check against what contains memory the most in your application, right? Cases we talk about um, using resources and not disposing them, right? And then they're there and keep eating into the device memory, right? Yeah, this is a very good place by which you could tell what's going on, right? You could basically like load up the app and go through the whole thing, right? Any new class it finds, it basically logs the class, and then it reads the memory. You could also take a snapshot. Uh, so take heap shots for the sake of isolate, right? So you could also take a snapshot of the whole thing, right? And yeah, so basically in the snapshots, it's in a similar process. Let me remove this console. Basically, you have all the classes right, that are currently running, how many instances of them are being used in the application. So cases where you have reusable components and reusable widgets, right? If they are used 5 times, you would find them here. Or this component is used 5 times, so you will see it here 5 times. But everything here is used just once, so you have it in instance 1. So cases where you have resources that you have used and maybe you did not dispose of them, right? And they are there, you will always see them here, how many instances of that resource you have and how much they are consuming. So that's exactly what the whole memory profiler is for. And yeah, I think the reason why we have something very short is because the whole app process was there's nothing more again in the application. Like okay, that's everything. There's nothing there again. Nothing there again. Okay. I think I should sit and ask if there are any questions before I proceed. Okay, no questions. Let me just proceed. So the other things that we have are the network tools and the logger itself, right? This is a simple debugger for breakpoints, right? I know your idea is like I think Android Studio VS Code allows you to be able to set breakpoint, set the IDE, but you could also do this from the debugger itself inside your Dart DevTools, right? So setting breakpoints, setting breakpoints, right? Um, Debugging against variables, pausing and playing your application, right? Pausing your application basically freezes the application, like nothing happens. Like exactly, like nothing happens. You can see like nothing happens until I go back and play it. All right, exactly. Then we see the application resume. So when I pause it like that, and yeah, basically nothing happens until I go back to resume. And that's the same concept by which the breakpoint works, right? Trying to set one. Show all exceptions. And I'm not sure why the debugger is not picking it. It's not trying to set the breakpoints. But ideally, all breakpoints are being logged there. It's similar to how VS Code handles breakpoints. You set the pick the breakpoints, and everything shows here. You could pause and play the debugger itself. Pausing and play stops the application. Same thing with the breakpoints. When a breakpoint is being hit, right, the whole debugger pauses, and then you should not be afraid. You could resume the debugger. I think even in VS Code also, if you catch all the exception, when an exception happens, it just freezes your application, right? Until you go back to play it. I think in VS Code, I think I have to set mine to ignore exceptions, so I can't even remember again. Except when I need to do heavy debugging, then that is for uncut for all exceptions. Okay. Two very sweet parts for me are network and login. Network and login. Yeah, but the network tool basically work the same way you have your network tab on Chrome. Everything is being logged. The method that was being the method, if it's a get method, a post method. Um, Let me even see if I can. Let me see if I could. Let me see if I can just make some simple API call. Mm. Um, let's see, network out. All right. So I tried to call google.com, right, from inside the code, and now we have here, you can see you have the method, get method, right? The URI that was queried, http.get, right? HTTP get method, google.com. You have what you have is here. You have the status code. It's a 200, a 201, a 30 or whatever, a 40 or whatever, a F or whatever, right? And then, of course, how long the whole request and response cycle took. At least from you hitting making the HTTP call, getting to the server and getting the response, how long did it take, right? That was all you have here. Um, you have a simple overview, the request URI, the method status. You have, I think, for regular API calls, it also logs with the headers. I think you have headers here also, yeah. So you have the headers, method, the URI, the connection information. You have the response header, right? I think the header that was sent back by the responding server. Then you have the request header. These are the headers that were set by you on the client end. And basically, I think the HTTP by default adds a default user agent, which is this a default encoding gives it a default content length of 0, and then the host is basically the endpoint or the URI I called, right? Then I have my response tab. I think Google responds with a web. This is basically a web page, so it's not a JSON response that's to be rendered here. If there are cookies, all the cookie will be listed here. So the cookie name and the cookie value, right? This is very important when very useful when you are working with APIs, right? Um, you could fire up the Dart dev tool and then work with your API, make the call in application in app. Cases where you have a passing error and you see an error happens on the UI, but then it tells you it's 200. And from there, you could tell what the issue is. At least the backend did not throw an error, but somewhere in the code, you must have mispassed some data. I mean, that is a type, statically typed, right? So type conversion is very is key, right? Yeah, so that's basically how the network tab works. Then we have login tab. Basically, all logs in your applications are being shown here. Everything, right? From custom logs down to logs from the Flutter engine. So everything log, like is here, everything log, everything to do with logging is basically shown here. Let's add a very simple log to our application and let's see if it logs. I'll be switching. I'm switching to my code editor. So yeah, this is my code editor. Let's see. Where should I log? Oh, let me even log from here, sir, right? Yeah, log from here. Let me log from here. Import that developer. Right. Then doing developer.log, we did some logging. Yeah, so I think by default, when we get there, you expect that, of course, it logs in your debug console, right? But you also expect that it logs on the login tool, right? In fact, that comes with the that comes with that dev tool. And how do you confirm that? We do that by simply confirming with the profile tool. Still here, this every log that has been logged, right? These are every logs, usually from the Flutter engine. And we added a new log, right? So we logged something just now. Yeah, it is. We did some logging. Yeah, so basically all logs also come here. The cases where you want to read your custom logs, right? You want to find your logs, you could, come and check for those logs here. So yeah. So if you check for this logs here, this one is returned from main.dat itself, the Flutter frame, then whatever any log that comes from anywhere, you basically have them here. So and you could search in the log, you could search through the log. We did some logging, of course, as you have here. So you could search for logs, right? Where you have lots of logs, and you see a particular log, you could just jump in and find them. All right. So what next? What else? What else? Yeah. The last but not the least, app size. This one is very important for measuring or doing site analysis. Cases where you feel like your app should not be as large as it is. but it's just kind of light in your eyes, right? To you, this is where you could do all the analysis, right? I think before we have a size analysis tool with that DevTools. I don't know if people did use this, but I used the APK analyzer that comes with Android Studio. Android Studio has an embedded APK analyzer that can analyze any APK you provide it and tells you what is in that APK and how much of space it is consuming, right? So yeah, the Dart DevTools comes with that's another APK analyzer on its own, right, out of the box. So what we do here is you click on import file, you import the exact APK, and I don't even have any APK to check that against. Do I? Let me see if I have at least. Um, oh, I don't. Yeah, well, ideally, that's what we do here. You import the APK and then you analyze size. And then, yeah, all your sizing properties are given to you. All resources in the APK, how much size they use, what is being used by the Flutter framework. I think it's called liveapp.so also. How much it's using, you have it that's here. Then you could also compare against two different versions of your application. I have some old APK and I have a new APK, right? I want to compare the two. I want to see which is larger, right? And what changes, what happened, why is the new one bigger than the old one? What changes happened to the new one that makes it very, very large, right? I could upload the old binary and then the new binary. And then yes, do a comparison. Unfortunately, I don't have an APK to uh, I don't have an APK to check against. But yes, that's what the size analysis tool is used for. Um, I think a similar tool exists that you could use for CI environments on right to do site analysis. I think it's called Diffuse. I think it's Diffuse by Jake Watson. We used to have that tool in the Android ecosystem back in the days, but it also works in Flutter also. But you could embed it on your CI and to do all this analysis also. So yeah, that's like the is it the nitty gritty now, I want to call it now, or that's like that's on Flutter DevTools in a nutshell. Yeah, so if there are questions now, I'll take questions.
Do we have questions? Thank you, Master Sam, for that breakdown. I even learned like new things so that I really don't have an idea about, which is really nice. Do we have questions? Hello, everyone. If you have question, you can drop it in the chat. You can raise your hand. Then I'm going to call you. Then you're going to ask your question, and you get a response to it. No question. So does it mean that everyone understands everything that has been taught so far? Like you get everything, all the idea. Oh yeah, it's going to be uploaded on the YouTube channel, and I'm going to release the link earlier for us, unlike the last one. So we don't have question about the class. Pastor Sam, it seems we don't have questions though. My OGs did this class; they understand everything.
Yeah, it's fine if there are no questions, right? I think I'm also going to share other materials, right? That
Oh yeah.
we can other materials and literatures that we can consume that shows how to and that does not talk too much story, right? So I think with these materials and this video will be shared, so you can always revisit them anyway. So there's also something I do. There's also one so that's what I do talk about when we talk about performance, right? I tell people that by default, you Flutter as an engine is very good, right? That I think we need to think about having to profile the application, right? Like Flutter is designed to run at 60 frames per second, right? So I said I'm cooking heavily. I should not like be having issues, right? So the very first rule of performance profiling is that you should only do performance profiling when you experience performance issue. Now, performance profiling is different from debugging, right? If you want to debug API response, you want to debug your UI, those are basic debugging, right? Performance profiling are things like, we are facing junks, visual structures, we have memory issues, right? Um, or maybe your Crashlytics tool like Sentry or Firebase Crashlytics telling you that the device OS is killing your application, right? So those are cases where you want to start, performance profiling. Or why is it killing the application? How much memory is the application using? What process are consuming more resources, right? So yeah. Yes, that's the question.
Hi, Hora Beck. I don't know if I pronounced that name well. Oh, sorry. Can you ask your question? You can unmute your mic.
Hi, good evening. So that's not my actual name. I just used one of my mails to join the meeting. So my question is, I tried using let me say a web view package on my app, and the debug version it works just fine. But if I build the APK, it's no longer working. Like it will just write web view not something something something. I don't know the error it's writing, but why how can that be possible? Something that works well in your debug version and is not working on your APK. That's my question.
Yes, yes, yes. It's very possible to have, right, that a process works on debug but not on release. At times, even UI, at times, some UI, it just happens that they work on debug and then on release, you have this Flutter gray screen. I think I've seen that one happen a couple of times, especially where you use where you have this incorrect parent widget issue. Maybe you use expanded wrongly, for example, and then it works in debug. Then on release, it just blows up. Those kind of things do happen, right? The very first thing you want to do is you want to build the application in profile mode, right? Profile mode basically mirrors the release version, but give you some other debugging capabilities, right? So building the application in release version, right, and then running the one thing you should know is that the profile mode only works on physical devices. So what you want to do is you want to compile a profile version of the application to a release device, to the physical device, and then debug against that profile version. That's that's one way you can easily debug issues that you can replicate on debug mode, but they only happen on release mode, right? What you want to do is you want to compile the application in profile mode on a physical device, and then connect the device to your machine, your Mac or your Windows, right? And debug against that profile version on the physical device. You would see that error throw up, and yeah, that's you can pick it from there.
All right, thank you.
Okay, Lukman. Hi, Lukman. You can ask your question.
Hello. So my question is, everything that you just explained. So, does it work on all the platforms, or it's peculiar to mobile alone, like the old dev tools and everything? Does it work for web versions, mobile versions, every other platform too? Hello.
Yes. That DevTools, right, is designed to work across multiple platforms, right? Where Dart and Flutter run. So it's called Dart DevTools. As long as it's a Dart project, right, it's running with Dart, right? Dart DevTools would work for it. So it's not a mobile only thingy, right? Yes. Was that answer the
I
question?
think he still has some questions. Lukman, you can just ask all your questions here. Thank you.
No, I don't have other questions.
Okay, all right. I believe we don't have questions from other people, right? Um, so we can just end the class. Thanks for joining the class today, Master Sam. Thank you very much. Today is going to be like it's not like the last day, but for this month, we're not going to have a Master Sam to come take us sessions for now. Another person will be joining us. Another, you know, we have plenty of guys like in this industry. So another person is going to be joining us, and we're going to be exploring a different topic, and it's going to be something that I know a lot of people actually finding it difficult to understand better. So for today's class, we're going to upload it on YouTube so that you can go and recap and watch if you want to check something, or you want to go over like the whole class from the beginning. And if you filled the form, you're going to get the link in your email. You're going to see it on Twitter, and you're going to see it on all the Flutter groups. That's very sure and confirmed. So thank you guys, and have a lovely night and a lovely day tomorrow because it's Monday. Bye everyone.
Bye, guys. Yeah, Bright. Thank you.
Yeah, it was
Bye.
really great.
Thanks.